in at this point. I'll make sure this one is good. And yeah, I'm from Huazhong University of Science and Technology. This talk is about my work that's done a few years ago. So the topic is about how we can leverage the BIM-based information to plan a robotic construction or robotic fabrication task in the real world. Is it working here? If I press this. Yeah, thank you. If you, and I know here recently construction robotics is a very hot area in linking traditional BIM and robotics community. If you talk about a robotic construction sites, you may think of, or you may expecting something like this, right? If you think of a typical construction site with different types of machines, escalated and or even human-machine collaboration, conducting different types of tasks. So there will be one common question is with the number increasing for these machines, how can we, or how do we human beings want the robots to behave in a harmony behavior, so that they can work coherently, work consistently, work efficiently, collaboratively with each other. So there are different. So back to this picture, there were different answers to this problem, but generally speaking, there are two mainstream methods to this problem. One is use kind of the centralized control and planning pattern. The other one is decentralized, where you allow an agent to do the task itself or in a group way. But for a conservative, the safety prioritized scenario like construction, I would say the centralized plan and control pattern will still be the dominant. But we welcome a hybrid way to kind of do a planning over the stereo, a fleet of the robots. And for we kind of thinking this problem for a few years ago and trying to do some conceptual work. So whether we can leverage the existing BIM information, or let's say digital twin of the body of the structure itself, and extract useful information, not only geometric information, but something related to the process of the component or elements, so that we can probably use that to guide or instruct the robots to plan their task and motion. So this is quite a high-level conceptual. We produce, or we try to propose a new framework called BIMfAR, BIM for automation and robotics. You can see within each of the specific construction project here, you may we define as alongside with the original design schema with all these elements inside. We also define a process and operational pattern for each of the elements, and the key here is the executor of each of the process related activities, including the robots itself, as well as our site workers and other human engineers that working alongside with robots. So I think this is some process oriented BIM framework sitting in the middle or sitting in the core of this kind of framework. So with such a framework, so the conceptualization comes to the next stage, where if we have this framework, how can we do with the current, how can we shift the current practice of construction? So we think of these features. So if we have this one, then a BIM or a digital twin can automatically update it with the elements, with the information or the data that's been sent, and captured and transferred from the individual region, individual agent, which is the robot. So it will create a non-delayed closed loop lifecycle information flow from both sides, well, from a central unit, decentralized unit with the individual agents, and will be helpful for updating the BIM model from a design model to a running real digital twin. And BIM itself serves as the central intelligence platform, not only showing the design blueprint, but also how the blueprint is going to be delivered to the real world. So this is the whole life cycle information flow from design to construction to maintenance, and then use those data information as a knowledge, as ongoing updated knowledge for informing the next stage of new projects that's being delivered next time in the near future. But if we what's next following this framework is you look deeper into all those robotic tasks. There is no single robot that can do all of the tasks within the construction domain. So we then further divide the robot tasks into 3 levels of automation. So humans still dominate the exact task. So it will be like human operated or remotely operated. And then many of our colleagues are doing heavy machinery, equipment steering or whatever. So you can see the heavy machinery manipulation will be the core topic around this side. And the second level of automation is something like to do with component manufacturing and construction. So where the robot will need to actually doing the real manufacturing on-site or along the site, such as 3D printing, the brick stacking, and the steel rebar tying stuff, right? And of course, the third level, which is with the higher level of automation, is something to do with surveillance or site monitoring. You allow the agent to generate its own plan to do the path planning around this site, and then they can sense, feel, react to a collision, whatever. So my focus is on the fabrication tasks within this big picture. And for the high level, as long as BIM can do the high level allocation of the task, but how we do the motion level, the low level in each of the fabrication tasks. So this is the current practice in this domain. Researchers have published a few interesting papers and efforts, right? I've listed just for references. These are interesting works in the references, and they usually use IFC as a traditional common way to exchange data. Based on that, develop some customized tool based on Rhino or Revit to allow a planning effort, to allow the planning with a human. So there are currently 2 major drawbacks of these current research at the moment. One is the scalability. Although these tools are good in terms of the functionality, and they still require a certain level of scripting and advanced design skills for ordinary BIM designer, if you like. He needs to understand robots, and understand the language that he's using, and also so it levels so raise the some difficulty for the uptake and employment of the technology. And also there's a problem with the operability, having to operate while outside of the normal BIM model view window. This is more like how the convenience of the software operability. So we are thinking whether we can doing a practical step forward following the BIMfAR framework. So this is where we call a RoboCon plugin, where we within the following the framework I was previously described. We then develop this this plugin inside the BIM software, which we use as example, as shown here in the Autodesk Revit. And these are the functionalities and workflows. I will just go over a few main workflows here. So the software or the plugin supports the construction organization from machine settings, construction classification, and the fabrication sequence, layout, environmental obstacle detection. So, and also for supporting in-situ printing workflow. So if you want to do a proper wall printing on the site, the software allow you to set the printer and the sequence, the coordination inside a BIM space. And also, besides 3D printing, we also support the in-situ mastering, where the designed normal wall can be break down into discrete brick elements, and you also allow to sequence the stacking of the brick, and then export coordinates with proper information to allow the planning of the robot motion. And also the component hoisting and installation, right? So these are the current functionality and workflows within this like initial development of the prototype of this plugin at the moment. And we've done a little experimental test with a in-situ downscaled in-situ wall, which is Chinese quadrant Go model within our lab. And going through this process using this software, you can design the model within the BIM software and plan a robot path encoding, taking around 15 to 20 minutes, and print out a little downscale component. Right. Okay. The conclusion of this typical work is we have 4 points here. First, BIM needs to contain definitions about robots and entities, process, and attributes to effectively support robotic construction tasks and motion planning. And the practical, in this work, practical plugin called RoboCon was developed for specific for Autodesk Revit software to allow integrated fabrication task planning in one single platform. And current features of this platform support fabrication tasks include printing, 3D printing, and component installation. And also, the last point is we found it useful to use it as a teaching tool for classroom teaching for undergraduate students who want to study digital construction, and they are very they are welcome to use such plugin to deliver their homework. So this is the very end conclusion point. I think there's a little video here to wrap up. Okay, thank you very much.
Thank you very much.